Does everybody know what I'm talking about? Okay, so you'll find this class notes should be very helpful because that's what we talk about in this class. So there are certain rules about the call stack. This reviews the call stack we have talked about in the last few lectures. The first thing is when a function is called, the line number after this call is pushed to a call stack. This line number is called return location. This is a place where the program will continue after the called function finishes. Means the function returns. If the same function is called in multiple locations, each location has a corresponding return location. That's the reason you need to have a return location, because if you, I want to just write it here. If you have a function, let's say somewhere, you call function f, and somewhere you call function f again. Sometimes that happens. Then after this function call, the program will continue from here. After this function call, the program will continue from here. After you continue from here. So each function call has a corresponding return location. It's not specific to the function. It's specific to the call. They have different line numbers, right? So you have line number, let's say 24, line 39, and line 51, something like that. That's what I mean. Each call has a corresponding return location. That's the second bullet. If a function returns a variable, and this variable is returned to a local variable in the encoder, the variable's address is stored in the call stack. If a function has argument, the arguments are stored above the return location in the call stack. And if a function has local variables, the local variables also stored in the call stack. You don't actually need to know who is above what. You just remember this will all be in the call stack. Should the local variables be above arguments or not? You don't really care. Compilers take care of that. But you need to know they are all in the call stack. If a function finishes, the top of the call stack is top. And the program continues from the line number stored at the top of the call stack. So every time you call a function, a frame is pushed to a call stack. A frame contains possibly 4. Each frame contains at least one piece of information. What is that? You always have that piece of information in the frame. What is that? Yes?
The return address?
The return, I call return location, because the address can be confused with the variable address. So the line number after the function call is always in the frame. And depends on the function, whether the function has argument, a local variable, or return anything. You may have the variable address, the argument, and the return the argument, the local variables, and the variable address may also be in the call stack. It's a review. Okay, any questions so far? Or as we did last time, if there's no question, I'm going to ask you a question. This is what we did last time. And I guess probably a few students have some questions. One student asked me a question yesterday about return, so I want to talk about that for just a minute. For the function, execute the return statement. The function will not do anything else. What do I mean by that? If you have a function, somewhere you say return, and depends on whether you return nothing or return an integer. If you have a return integer here, you need to return an integer, a variable. Let's say return 0, okay? If the function doesn't return, you can say void. That means the function does not return any value. Then you say return without anything after. Compiler will check whether they match. If you say integer here and you have nothing here, compiler will tell you you are making a mistake. If you say void here and you have a value here, compiler will tell you you are making a mistake. For those people not taking notes, I encourage you to take notes. So they have to match. Okay. Once the function says return, whatever after this is not executed. After return, if you have anything after return, if you have anything here, this will not execute. If you have anything after return, then the compiler will actually give you a warning, telling you, are you sure? Because whatever you write here has no effect. The function does not do anything after that. Most likely, your return will not be just this way. You will put the return inside an if statement. You say if something is true, then you may do something and then say return. Again, depends on your return type. Is void or an integer or character, you need to return the corresponding type. So what this means if this is true, the function will do this and will stop here. It will no longer do anything after if the if condition is true. So you can think of this as the same thing as if something is true, you say return, and you say else. Yes?
You said that we get a warning if there's any code after the return statement. If it's in a conditional statement like that.
It's in a conditional statement, you will not get a warning because return doesn't always execute, right? However, if you have anything after this return, let's say that's not a break it. You have something after return, you still get a warning. Does that make sense?
Because that part would never execute.
Yes, this part will never execute. But if you don't have anything here, you have something here, since the if condition may not be true, it's possible this part of the code go wrong. Therefore, the compiler says, well, okay, that's what you want. That's fine. If it's after this return, then there's no chance that will execute. So compiler will give you one. Okay. Any questions? All right, if there's no question, let's go back to this function. Last time I gave you some time to do this, and today I think let's do it again. Take out a piece of paper and draw the changes of the call stack. Since we did last time, I hope this time it will be a bit faster. Okay, please take out a piece of paper and write down how the call stack will change when you run this program. draw the contact, the change to the contact here. Okay. Tell me if you have questions. I just go through one. Not yet? Okay. I can put the rule side by side. Do you want me to do that? Raise your hand if you want. Okay, then just keep it the way. You should know how to draw contact very well because everything we learn from here depends on the fully understanding of contact. And from my experience, not understanding the contact will pretty much make you not understand everything else from here. Thirty seconds more. Okay, Andrew, can you come over here and help us? All right, you can bring your note, but maybe it's easier if you can bring your note, but can you also draw it here? Tell us how you solve the problem. Thank you. That's it, whether you agree with him. It's the Can you explain? Moving forward.
This is the main function, so this is the t variable that's been initialized, and then this is the address of t, and this is the initial value.
Okay?
So it's on line 128, so we return 129 here, and then it's the address of 100, and it passes 2, so I'll write 2 here, and when I did it, I just gave it an address of 400. Then there's A, which initially has no value. I just made it 401. And then B, which also doesn't have an initial value. I gave it 402. And then, let's see, it asks if this n is equal to 0, then to return, since it's not, we go to the next line, and A is a function call, so we pass n minus 1, and that's on line 120, so I write line 121. This is another frame. So 121, the address of A, which is, it's going to pass the value to, I write address, A has address 401, n has been passed as n minus 1, so since n is 2, n becomes, in this frame, 1, and I just gave it an address of 403, A 404, has no value yet, B 405, no value yet, and then it asks again if n is equal to 0, n is not equal to 0, it's equal to 1, so this begins another frame because A is going to pass n minus 1, so A has an address of 404, and this is still on line 120, so this becomes line 121, address 404, n, this passes n minus 1, so 1 n becomes 0, address 406. If n is equal to 0, return 0, but I guess these still have no initial value. So if it passes 0 from here, this passes to the address 404, which is A, so this becomes 0. B becomes A plus n, which is 0 plus n, so this becomes 1. This passes to address 401, so this becomes 1, and B becomes 1 plus 2, so it becomes 3, and this passes to the address of 100, so this goes here, and this turns to 3. So it ends up with T equals 3.
All right, do you agree with me? Thank you. All right, thank you. If you are still not comfortable with this, you need to do more practice. Now, some people are confused about this kind of function. This is a recursive function. The function calls itself. But recursive function has nothing special. Recursive function follow exactly the same rules as I mentioned earlier in this handout. Recursive function code is simply a function code. There's nothing special. And I want to emphasize that when you have a recursive function call, I have already said a few times, the symbols have no meaning for computers. When you are inside the computer program, inside computer, the symbols A, B, and T are all gone. They don't exist in computers. When you do GCC, the symbols are all being removed. What the computer knows is the address and the variables. Yes, please.
When to return the line will always be 121.
Which one?
After the first.
This one?
Yeah.
Okay.
Is that 121?
Can you, I don't answer your question. Can
Is
you
that 121?
Yes, line 121, because I call function f in line 120.
So the second one is 121 too?
It's, yes. Where do I call the function? Where do I call function f?
Oh.
The first time is 128, right? So first time the return location will be 129. The next time I call the function is at line 120, so the return location will be line 121. Yes?
Those, instead of actually being line numbers, they're memory locations. right?
There are memory locations.
Does that line have 2 unique memory locations? Or is
Each
that-
line has a unique memory location in your computer, yes. GCC takes care of that.
Since it's just line 21 for both of them, is it the same or is it?
That will be the same, yes. This will be the same, but in reality it's not 21. It's a number, some strange number, but controlled by GCC and operating system. Okay, but that 2 numbers will be exactly the same because you go back to exactly the same location. Right? Does that answer your question? Does that answer your question? So we have symbol, address, and the variable. I've said many times, symbols do not exist in computers. That's one of the source of confusion because some students will say, what's the relationship between this n and that n? There's no relationship. They don't exist in computer. The only thing exists will be address and the variable. So that n, you can rename it to whatever you want to rename. Compiler would all take it out and convert that into address. So from now on, if there's a recursive function call, it is just a function call. There's nothing special. So you will follow exactly the same rules. Every time you call a function, you put your frame. Every time the function finishes, you pop a frame. Exactly the same rules are applied. Okay. Any questions? Why do I talk about call stack? Because I discovered that it's almost impossible to understand recursive call if you don't understand call stack. Because many students will get confused about this n and this a and b. You can see n appears 3 times. But if you understand call stack, you will say symbols are irrelevant. What's important is the address and the variables. Okay. Any questions? So we have seen how to, now remember once you, okay, a few more rules. A function, this looks like low on link. A function can see only its own frame. Oh, yeah. When you are inside this frame, when you refer to A, that will refer to A in this frame. The function cannot see things outside its own frame. And as I already mentioned, once the function returns, the top frame is popped. So, if I have a function written this way, and inside do whatever I want to do. Let's say A equal to B plus 1, B plus plus, and then somewhere I call a function. I am going to use n equal to 5, m equal to 9. I call a function A and B. In the call stack, we'll have A and B as the argument. When we call A and B, A will be 5, B will be 9. Inside the function, I say A equals B plus 1, so this will become 10. And B plus plus, this will also become 10. As the function returns, here, this frame is popped. So what is the variable? What is n's variable?
At the main function, is it have to be f, m, and n, not a,
Which one?
the last one f.
This line?
Yeah.
What's your question?
Oh, I mean, you said it's 5 and 9, then
It's 5 and 9 before calling the function. After the function call, what's the variable of n?
No, you didn't.
He means if you
You
should
didn't
put
use it.
F and pass N and
it's
N
like
instead of
it's
A
an
and
A
B.
and B, but you.
Oh,
the
yeah,
phrase
yes,
says
yes.
M and
Okay,
N,
okay, okay.
so, yeah.
Sorry, that's a mistake. Thank
It was
you.
confusing me, so.
Thank you. Is that you?
Yeah.
Okay, thank you. Is that what you want to say too? I saw you raise your hand.
No, I'm saying
Okay, what's the variable n? What's the value of n? Yes.
I wasn't paying attention to the question.
Okay. Do you understand the question now? You can say no. Then I say it again.
No.
Okay. I'm calling a function with n and m. When I call a function, based on rules I have mentioned, I have an argument a and b. A will become 5 because n is 5. B will be 9 because m is 9. Inside the function, a is b plus 1, so it becomes 10. B is b increment, so b becomes 10. After the function returns, I'm here. First, there's no a and b here. The function has already finished. A and b are gone. So what's the value of n?
5.
5. What's the value of n?
9.
9. Do you understand now? Okay. Any questions? The only way you can change something in a coder is by return. If you say here, you'll say return b, and you put the integer here, then you'll change to m equal to this. Then n is still 5, but m becomes 10 because you have returned. Any questions about this? So what this means is you can change a variable in a coder. This we call this, whatever function this is the coder of f, because that's a place we call f, so we call it the coder. You can change a variable in a coder by using return, right? In this case, return b. Yes,
How would I return both the value of a and b?
that's something I'm going to talk about next.
Okay.
You can change a variable, and you can only change one variable. If you want to do 2, you're out of luck. Now here I'm going to do a little bit, who is taking 270 or has taken 270? Okay, do you learn binary logic?
Yes.
Right? Do you know why you use binary logic? Why is 2 so special? Why do you use unary logic? Have you thought about that?
It's always true or false.
True or false, you need 2. Why don't you use 3? Why is 2 so special? Has anybody thought about that? Yes?
Because doesn't it translate to either on or off?
Ah, no. So why don't we use 3? Has anybody thought about that?
Computer doesn't,
yes?
computer doesn't understand.
Computer doesn't understand. You can make a computer understand if you want to. Yes?
It's difficult to make an inverter if you have ternary logic.
Well, but does 2 give you everything you want? Yes.
It would just be more costly to design the hardware to read different ranges. Like that.
So, okay, so here we can do 1. If you want to do 2, it will be hard using return. Okay? But here I want to talk a little bit about the difference between 1 and 2. 1 and 2 are fundamentally different from number theory. Why? Because for any number, for any positive number, let's say k, you can find a number, let's say n, such that 2 to the power n is k. So suppose k is 8, the n will be 3. Right? A is cubic of 2. If k is 16, n will be 4. If k is 10.5, n will be 3 point something. Are you with me? If k is 0.5, n will be minus 1. 2 to the power minus 1 means 1 over 2. And that's 0.5. And if you want to say something smaller than 0.5, for example, if you want to say if k is 0.2, so we'll say 1/4 is 0.25, 1/8 will be 0.125. So if k is 0.2, so this will be 2 minus 2. This will be 2 minus 3. So if k is 0.2, this will be minus 2 point something. Right? It's between minus 2 and minus 3 because 0.2 is between 0.25 and 0.125. Is everybody following me? Does this make any sense? So for any number, positive number, you can always find another number n such that 2 to the power n is k. This number may not be integer. Right? Yes?
But you can also find any number if it was 3 power n is equal to k, right? Or even
Yes.
if 4 power n is equal to k or anything like that.
Yes. So this property applies to 3 as well. So for any number, for any positive number, k, you can find a number, let me say t such that 3 power t is k. So in this case, 2 can do everything 3 can do. 3 can do everything 2 can do. K, t, and n will be different, but they can do the same thing. How about 1? You can't. For any power, let's say m, it's still 1. So 1 cannot do what 2 can do. So to answer the question, why do we learn binary logic? Because 2 can do everything 3 can do. Okay. So going back, does everybody understand this? We'll see this again when we talk about binary search tree. But you have to understand 2 is fundamentally different than 1.
So we use one as binary bit because it's unique.
Because binary is powerful enough. 1 is not powerful enough. 2 can do things 1 cannot do. 2 can do things 3 can do. So in terms of capability, 2 and 3 will be the same. Or 4, or 5. Does that make sense? We'll see this again when we talk about binary search tree. But let me go back to the question. If you want to change one variable in a coder, you can use return. If you want to change 2, you can't. We need a completely different method. Okay. So, if you want to change 2 things in a coder, since return can only change 1 thing, the designers of C language came out a different method. It's called pointer. What is a pointer? Pointer means the variable is an address. And the syntax is the following. You have a type. This will create a pointer. And the type can be, for example, integer, character, double, and later on when we talk about types we create, it can be new types. What this means is PTR is a pointer, and what we need to say more than that. When it is a pointer means its value is an address. And furthermore, at that address stores a type. For example, integer. So if I write this way, integer asterisk PTR, means PTR is going to be a pointer, and its address was, you will store an address. That address will be an integer. So if I say integer A, let me initialize to 264. So in the call stack, you have PTR, you have A, suppose this address is 100. Currently, PTR is not initialized because I have not put anything on the right hand side. And A's value is 264. This will be symbol, address, and the value. So then I will say PTR equal to ampersand A. This means get the address. In that case, the value will become 101. You can do something different. You can later on you can say integer b equal to minus 5, and b has its own address 102, and this minus 5. You can say PTR equal to ampersand b. In that case, this becomes 102. Any questions so far?
What if you print PTR?
If you print PTR, you will print this value.
the address, not
It's
the
an
value.
address. It's probably something strange value.
How do you get the value of PTR? If I want to
Okay,
print-
so if you print, you need to use percentage %P. So to mean you want to print a pointer. Let's say I put a new line there. I say PTR. You get some strange value. As I already said, you don't control the address. So the compiler and operating system will give you an address. Do you want to see it? I can show you. Does anybody want to see it? Anybody want to see it? All right, I show you. Okay. So I'm going to write this program. I need to include the header file because I'm going to use print. I'm going to include another header file called standard library because I need to use a particular constant. I'll talk about ARGC, ARGV in, sometime later, maybe in a week or two. The arrangement function should return X is success or X is failure. If your program does what you want it to do, your program should return X is success. If your program cannot do what you want it to do, your program should return X is failure. In what case your program cannot do what you want it to do? For example, you want to process a file. You want to say, I want to take student database. I want to find all the students that are taking EC264. Okay, suppose that's what you want the program to do. And for some reason, the database doesn't work. You cannot find the database. So the program cannot do what you want it to do. In that case, your program should return exit failure. We'll talk more about that later as well. So suppose I say A equal to 264. be equal to -5. This means PTR is a pointer. When I say pointer means PTR's value is an address. Moreover, that address is an integer. Why do I know it's an integer? Because I put integer int in front of an asterisk. Okay, so if this is what you want to do, ampersand is shift 7. That's the symbol. Shift 7. So if I print, I will get the okay, maybe I should tell you this. Remember in assignment 1, we said you should always turn on warning messages. Does everyone remember that? Assignment 1? And I always tell students work too hard. Students work too hard, really. They will type GCC minus WAL minus shadow minus G and so on. And I don't because I'm lazy. So what I do is I create an alias. So that whenever I type GCC, it will automatically add the warning messages. If you don't know how to make an alias, go to look it up for Unix or Linux. So that I type GCC instead of typing all this long command. That's how you save time, right? Students work very hard. They keep typing this very long command. Okay, so when I say type GCC, it becomes this. As I said before, if I don't give -O, the output will become A.out. So there should be A.out here. If I type A.out, that's the address. That's the address of A. If I execute a program again, let me execute a program. As you can see, the address gets changed. I execute the same program again. The address of A is different. Did I answer your question? How do you print?
Yeah.
Percentage at P.
Well,
You probably don't want to print because it doesn't make sense for you to print. But if you really want to print, you can print.
what if you put star PTR?
No, we are not there yet. Yes, you have a question.
What if you initialize PTR to A without dereferencing A?
Okay. If you initialize P to A, I was about to talk about that in a moment, but that's first understand this part, okay? Alright? Then let me answer your question before I answer yours, okay? Because there's a certain order. You have a question? Go ahead.
No.
Okay? Are you sure?
Yeah.
Yeah. How do
Yes.
you get the A dot out again?
How to get A.out again? GCC. That's your question?
And then,
Yes?
so I just say GCC and the .z file that I want.
Yes. If you want to give a file as the name is executable, then I can say, in that case, I simply, if I don't give minus lowercase o, the output file name will be A.out. Did you answer the question?
Yeah.
Okay? Yes.
Can you put an and sign before a PTR?
What sign?
And sign to the address sign. The sign before A.
Can you put
And-
ampersand
yeah.
this? No, you can do that on the right side of a sign equal sign. You cannot do on the left side equal sign.
Oh
Do you know why?
no.
Okay, so you're asking that question. That's good. Okay. So coming back to this, what do I do when I put an ampersand in front? Address, right? That's what it says here. So if I put this, probably should throw this away. If I do this, what do you intend to do?
The address of the pointer.
You intend to multiply the address, right? If you put on the left side of assignment, equal sign, you have left side, your right side equal. Left side means you want to change it. Right side means you want to read it. Everybody understand that? Right? If you say A equal to 10, means you want to change A. Right? If you say X equal to A, means you want to read A and change X. Does everybody agree with me? So if we say ampersand PTR equals something, what are you trying to do?
Change the address.
You are trying to change the address. Can you?
No.
No. Compiler will say you are crazy. Okay? Does that answer your question?
Yes.
Alright. So answer the next question is what's ampersand PTR? I understand many people have confusion about pointers, and I don't blame you because it is very confusing. And I will encourage you to read this because the same notation, the same symbol is used in many places. Okay, I cannot move fast enough. Let me just jump. I need to find the page. Okay, maybe this is faster. Oh, I think I went too far. Okay. So, sorry, you cannot see it. This is in the class note, page 122. So the first here is you create a pointer. And the second is what we have seen, you try to get the address of VAL. Now the same symbol star actually has 4 different meanings. Depends on how you use it, and that's why it's confusing. And this table summarizes the different meanings. If you put a star on the right side of assignment, it means something different from you put it on the left side of assignment. And it's also different if you put star between 2 numbers. In this case, number 5 is probably something the easiest to understand. You put a star between 2 numbers, that means multiplication. Okay, any question about that? If you put star on the right side, that means you take PTR's value as an address and go to read the value at that address. I will show you an example. If you put on the left side of assignment, it means you take PTR's value as an address and modify the value at that address. This table, you'll see this table, you should read this table many times and memorize it. It's not because I will ask you to memorize for the sake of memorization. It's you are going to use it so often, you'll memorize it. Just like what's the product of 3 times 4? 12. You don't have to count. You are going to use that so often, you are going to memorize it. This is like part of dictionary. You can look it up, but it's going to slow you down. Okay, I'm going to give you examples. And for the people they don't memorize this, they will get confused. So, first, if I say integer PTR, and I create a character, let's say X, sometimes I get questions like this. Is it good? No. Why not? Different types. Compiler will give you a warning. You are looking for trouble. So don't do that. You want to make sure the types match. Okay. So that's bad. Now the next thing I can do is I can say, I just used another piece of paper. Suppose I use integer a equal to 4, and I say integer asterisk PTR. This will be what's in my call stack. A will be 4. Let me give the address 100. PTR will have its own address, so that will be, let's say 101. Current is garbage. Then I say PTR equal to ampersand A. That makes it 100. I go to say integer, let me use C, equal to -5. So C, it has its own address, it's -5 here. So if I say PTR equal to 17, now this is a start PTR, and there's no type. Notice that there's no type in front. It's not integer star. It's different. There's an integer here, there's no integer here. Okay? So, line 2 here corresponds to rule number 1. You are creating a new pointer because you have integer in front. So I will say line 1, 2, 3, 4, 5. Line 3 corresponds to rule number 2. You have an ampersand in front. Line 3. Line 5, which rule does it correspond to in this table? Number 4. So number 4 says we're going to, it's left side of assignment. We're going to take PTR's value as an address. PTR's value is an address, it's 100. And we're going to modify the value at that address. So the right side is 17. We'll take 100 as an address, modify the value at that address, so this one will become 17. You are modifying A. Yes?
Whenever you assign 100 to the pointer, does the 101 stay? Because you have two.
Which one do you want to do?
Huh?
Read the code to me.
Well, you're assigning the address of A to the pointer.
Yes.
So in your call stack, you originally given the pointer the address of 101. Whenever you assign that address of A, does the 101 stay or does it go away in the call stack?
I don't understand the code you want to write. Can you read the code to me? PTR equals something?
In line 3, you have pointer equals the address of A.
Yes.
So you're giving the value of the address of A, which we have 100 in the call stack. You're giving that to the pointer.
Yes, I give to the value. You never change your address, okay? And? Keep going.
Okay, so right now that has an address and a value that is an address? So that's.
This value is an address.
Okay.
Why is that address? Because I say it's a pointer. Pointer says the value is an address.
Okay, that makes sense.
Does that answer your question?
Yeah.
You can never modify the address itself. You can only modify the values. Okay, does that answer your question?
Yes.
Okay. Now, I misunderstood you. Maybe I was wondering whether you were asking this one.
No.
Okay. Does anybody want to know whether this could, anybody want to ask this question? Can I assign a value to PTR? No, why not?
Because 100 is not address.
100 can be an address. But how do you know 100 address you have access to? Right? I already showed you the address is assigned by the operating system. What happens if the address happens to be 400? 100 belongs to somebody else. Right? So you say, I want to use address 100. First you get compiler warning. If you run a program, your program will crash. Because you basically try to break into somebody's house. Right? Like you live in a dormitory, university give you a room, you try to break into somebody else's house. Operating system will stop you. It's called segmentation fault. So this is bad. The next, line 6 will say C equal to star PTR. So what will this do? Which rule does this correspond to? Which rule does this correspond to? 3. Why?
Because the star PTR is on the right side.
Because star PTR is the right side. So if you read this rule, right side of assignment, you take PTR's value as an address. PTR's value is 100. You are going to read the value from that address. You are going to read, and that value is currently 17. So this line is equivalent to C equal to 17. Therefore, this will become 17.
Can I understand this? The star sign is inversely equal to the ampersand. So
I
star
say that
sign
again.
equal to 1 over ampersand.
Star sign equal to what?
1 over
1 over?
ampersand.
I don't understand what you mean.
And then
I don't
you
understand what you mean.
I thought they're inversely equal. Then you put star PTR.
They are not reversely equal. They are related, but they are not reverse of each other. Because ampersand can only be on the right side of assignment.
Okay.
You cannot put the ampersand on the left side.
Yes, I just try to understand. If you put star PTR and PTR equals to ampersand A, then you put star ampersand A equal to 7.
Okay, you are going too fast. Can you read that again?
Star PTR
Star PTR
equals to 7.
equal to 7.
Sure. And then because PTR equals to ampersand of A,
Okay, PTR's address, the value is the address of A, okay? So I'm going to change the value of A. Okay? Keep
Yeah.
going.
yeah, that's I just try to understand to let me check if I was wrong or right.
If you do PTR equal to 7, star PTR equal to 7, first, you should not say PTR equal to a number. That's bad.
Yes.
Okay?
Yes.
So you should say star PTR. This is bad because you don't know what address 100 means. Okay? You say star PTR equals 7. Based on that rule, you take PTR's value as an address, you multiply the value at that address to multiply the value of A. So this is equivalent to A equal to 7.
Yes, that's what I'm trying to say. Okay.
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 So I answered your question about star. Sorry, I think I forgot your question. Did I answer your question?
A while ago I asked, I was waiting for you to go to.
I think you were asking what happens if you say PTR equals something, right? Was that your
Well, it
question?
was without dereferencing a variable, but it would do the same thing as PTR equals 100. So.
Okay, so I answer your question. Yes, go ahead.
So, did you then move the pointer to, is it pointing to, is it still at 400? Is the value?
It's 400 because here I say this is 400 because of this line. Because this line says PTR equal to address of A. Address of A is 400. I changed to 400 because I want to say this is bad.
Okay.
Okay? That's the reason it's 400.
I got it. All right.
Okay,
So
any
yeah,
other?
if you were to say,
Yes?
if you were to do star PTR equals something else, let's say 5, then
Star.
it's going to change.
Say that again. You want to do what?
After line 6,
After line 6
if you say star PTR equals 5,
equal to 5.
is that
Yes.
that's going to change A to 5?
Yes.
Okay.
Okay, so let me show you if in case you don't believe me. It's not because you don't believe me, because I know some people will feel more comfortable if I show that, right? So I say star PTR, oh, I should not capitalize, equal to, what do you want to do? 30, how's that? Today is January 13. And then I say B equal to star PTR